Tool and fullering developed over 200 years ago in Britain before the availability of a rolled concave section. The technique was developed to shoe fast-moving ridden horses such as racehorses and hunters. The section was designed to mimic the concavity of the solar surface of the horse's foot and enhance grip whilst offering protection to the hoof. Although predominantly 5/8 of an inch square is used today for tool and fullering, there used to be a variety of sizes used depending on the horse's individual requirements. With the development of rolled fullered concave sections and machine-made shoes, the art and skill of tool and fullering has almost been forgotten. Fortunately, the skill has not been lost completely thanks to farriery competitions held in Britain and North America. The hammers should fall in line with the forehammer following the hand hammer. The hand hammer sets the rhythm and speed. It is important not to race. Allow the hand hammer to dictate the position of the blow for the forehammer to strike. The hand hammer indicates the force and speed required. It is important that the striker hits any tool squarely. No verbal communication is required. The hammers do the talking. The striker should be thinking at least one hammer blow ahead of the hand hammer, predicting what will be required of them. This makes for a good partnership. The block is made from case-hardened mild steel with a stem that fits the hardy hole, which is either drawn from the block or welded within the block. Welding the stem straight onto the bottom of the block will not create enough strength to withstand the pressures placed upon it by the floor hammer. The tooling block has a slight radius on the top surface, arcing from the front to back, from one end of the section groove to the other. This means that the centre of the block has a deeper section groove than the ends. This in turn allows the section to be drawn more if required by working the section through the block closer to the ends, where the section groove is slightly shallower. Between the block and anvil face, a pad of lead is placed to reduce the block from bouncing, which in turn maintains accuracy. Another tip from Jim is to measure 10 inches of 5/8 square and run this through your block. You can then calculate how much the material draws and apply this ratio to further shoes that you make. Note the triangular shape of the section once it has been put through the block. The guide fuller's inner edge matches the angle of the outer edge of the section. The guide fuller should have a long handle for comfort when guide fullering long sections such as in the making of bar shoes. The mark created by the guide fuller blade is just to the inside of the peak of the section. The splitter is a sharp, narrow fuller with a long handle and long blade to cover more distance. The splitter is angled towards the outside of the section slightly to prevent the finished fullering becoming too coarse. With the splitting procedure complete, note how the outer edge of the section has been forced up and out to compensate for the stretching of the material on the outer edge when the shoe is turned. The hunter fuller is narrow with a short blade and a slight radius. This allows the hunter fuller to smoothly work around the bends of the shoe. The hunter fuller is only used once the toe and branches have been turned. The hunter stamp is quite narrow. This prevents damage to the fullering and helps provide pitch. The hunter stamp creates the area for the shank of the nail to sit in. The pritchel should be sharp with the cutting end the same shape and size as the end of the hunter stamp to prevent steps in the nail holes. Some time and effort must be spent to fine-tune the tools so they all work together to create the desired tool and fullered shoes. Finally, there are several ways to clip tool and fullered shoes, but care must always be taken to avoid damaging the section when pulling the clips.